Hello, so I'm going to continue on this contest. There is one problem that I haven't gotten around to solving, which is this one. So this is just a timer up for maybe stopwatch actually. So stopwatch for 30 minutes, like this. And let's go. So we have, yeah, I should probably do something like this. So the problem says that minimum distance to type a word using 2 fingers. So we have a keyboard, right? So there is this keyboard. So we have a keyboard and English. We have English uppercase letters in it. So we have some and then A is located at coordinate 0, 0. So we have A is at 0, 0. And then B is at 0, 1. And then we have P. So basically every letter. So you can just, it's just like you number the x-axis 0, 1, 2, 3, and then the y-axis 0, 1, 2, 3, and so that makes P be at 0, 1, 2, 3. So makes it be at 3, 2, right? So P is at 2, 3 actually. So at 2, 3. And that's what we are doing here. And then we get Z to be at 4, 1. And then what we get a word, right? And then when we return min total distance to type it using 2 fingers. Okay, what does that mean? And so, and distance can be calculated as, so distance between these 2 points, x1 and y1, and with x2, y2, is equal to basically just the absolute difference between the x coordinates plus the absolute difference between the y coordinates. Okay, now the initial positions of your 2 fingers are considered free, so initial positions don't count. Okay, don't count in distance. Okay, 2 fingers do not have to start at the first letter or the first 2 letters. Oh, interesting. So okay, so this is interesting. So if we take a look at the first example and just analyze that, right? So we have word is equal to cake here, and we have, so the example says you could do this, but, and so we return 3. But I don't get why finger 1. So basically, I'm guessing here finger 1 on letter C. So that's the start. And then you put the other one on A. So the distance there is 2. And then why is it the same finger? Oh, maybe it's the same. And then it's the second pass you do KAE. And then for the second example, we do this, the word is equal to happy, right? And then what happens is this. Okay, but so H, that's cost 0. Going on A, so that's still 2. So 2, because I'm guessing you don't go diagonally, you have to go like up to B and then from B to A, and that's why it counted as 2, right? Why is the cost 2 if we don't count? Oh, the initial position doesn't count, but the last one counts. So that will mean that B and A count, right? Okay. So what we want to know is minimum total distance to type using 2 fingers. One thing I don't understand is why is the cost, because you'd have to use your 2 fingers, and why is, oh, because the last place was A. Oh, I see. So the first you do CA with one stop, with doing one pass, and then this one, and then you do these 2 with 1, and then you use the other fingers to do 2 P's, so same place. And then now you'd have to use this finger again, but it was in A, so you have to move it to Y. So you start from where you ended, right? So this definitely feels like a graph, and then minimum, maybe some graph, and then find minimum shortest path or something. Oh, it's actually dynamic programming. So maybe not that. So basically minimum total distance to type using 2 fingers. So we have multiple choices, I'm guessing. So what would be the state here? So the state is we wanna cover the entire word, right? So, well, position at word, right? Let's call that I, and then the current position in the keyboard, right? So let's call that X, Y. Keyboard. So maybe kind of a 3D DP array. Okay, so how can you go from one to the other? So what are the choices at any given moment or something like that? Okay, so what are the choices here? So what are the choices? I guess what's not clear in my mind here is what are these fingers represented? So I think, yeah, so my thinking here was right. So IJ means we are at so this is the state that we need to figure out. Or maybe I could just have some kind of helper that says IJK, right? Where basically, and then think about the choices. So here it's minimum distance to type, minimum distance to type using minimum distance with a finger on character I and another on G with K letters with and at position k plus 1, or with k letters written in Word, which can be translated as at position k plus 1 in Word, and we want to figure out where to put that character here. So here, that means the choices would be, well, either finger 1 or finger 2, right? So go to character k plus 1 using finger 1 from character I, right? Or go to character k plus 1 using finger 2 from character J, right? And so with this one, the cost would be, distance from I to k plus 1, right? Which you need to figure out using the J and k plus 1. So that means we need an easy way to figure out the coordinates of a letter. So maybe preprocessing step where a map from character to coordinate, map from C, which is character to coordinate, right? And an easy way to find that out is we have string dot uppercase, right? So I'm guessing we could just say 0, 1, 2, 3, 3, 6. So each row, we know that each row has 6 letters, right? So we can just go through them and do that, right? And then here take the min of the 2 choices. So to do first that, well, we just say, okay, let's first import string here. So import string, and let's say string dot, I think it's something like string, well, let me just first import string, and string dot upper ASCII, I think it's uppercase. Yep, so let's take that, keyboard, okay, alphabet, and keyboard is the map, right? Which would be something like this. And then we'll just go through for C in, well, we will need to enumerate, right? C in alphabet, maybe we need to enumerate. And then, well, keyboard for C, well, it will be, the row would be by doing C divided by, not C, but it's like index divided by 6 and modulo 6, right? That would be the and then here I'm just going to print it to make sure everything is correct. And then we will need to start our helper function here. Okay, looks like it's good. So P, let's see P here. P is P is 2, 3, which is good. Cool. Now we will need to have our helper function here that has I, J, K. And that one will need to start out as, well, we'll need to return a helper starting from the coordinates of the first letter. So that would mean word 0. So can word be empty? No, it's at least 2 letters. So word 0, well, X and Y, that's the coordinate of word 0. So that's keyboard of word 0 here. So we pass X, Y. And then, well, right now we have processed but we will need to try the first one. The cost is 0, right? So we need to take the min of okay, I'm not sure if we need to do the min. Can we? So if we process it more than the length of the word, we are done. Turn 0, and here we can do both, right? So helper for so finger would be on character k+1, right? So k+1 here, j, and we have processed it now k+1. Or the other choice is still here, and we are here at k+1, and we need to take the min of the 2, so we need to take the distance. So here, well, the distance would be from the coordinates to this coordinates, and the coordinates here is from character I, so keyboard of word I, right? And here keyboard at word k+1, right? So going from I to k+1. So we need to find the distance there. Here we need to find the distance from keyboard at position k+1, j to k+1. And then, well, we need to return the min of the 2. Okay, I think I need to just make this a little bit more. So this is choice 1. Choice 2 is this one. And I need to define choice 1, choice 2. And then def dist between x between point 1 and then point 2. Well, then, well, x1, y1, x2, that's p1, x2, y2, that's p2, and then we could say return just what I said here with the absolute. Difference, right? And then here we have the choices. Now what if k is length of word minus 1? So right now, processing word K, so no. So we processed one word, so that means here, while we are going to the second word, which is K, the word after that, which is K plus 1, so we try to go from I, and we try to go from J, and once we process it, that means we already processed K plus 1 words. So next time, we'll try to process 2, right? So let's try this. Okay, so let's try and see if we can solve this. So let's see what's wrong here. So the input is just cake, right? So let's see why this is failing. Okay. So not this here, definitely not. It's this one. So let's run it first. Gives me 1. Should give me 3. So now that's actually good because we are doing okay. So the first word doesn't have any cost, so that's good. So well, let me just jump to this here because that one gives us a keyboard like this with the coordinates, so that's normal. Now, okay, so the distance now between, so now at C, so I should be trying to go to A, right? So here, I'm trying the distance between 0, 2, and so what is 0, 2 in keyboard, right? So I will need to have the keyboard here displayed. So the distance would be that I get for this here. So if I evaluate here, what is the word at I? That's C, so that's the first one, that's good. What is the word at K plus 1? That should be, okay, so that's the problem because K here is 1. Okay, so yeah, because the indexing here, okay, that's the problem. So I should say K, and finger here is at position K, and here it's at position K, and we have processed. So when we are at 1, we are at position 1, and we have processed 2 letters. Yes. And here we have processed, when we have processed the entire word. Yeah. So that gives us 3. Good. Now if I do it for happy, I should get 6. So I get 9. So that's a problem there. What about new? So for new, I get 0, which is very bad. I should get 3. For year, it's problematic. Okay, let's first fix new, or maybe let's just even try. Let's try a couple of other. Let's say A B, and let's say A B C. Let's try these 2, and of course try them with the correct solution here. So okay, so for AB we expect 0, right? So let me first just try these easier ones. So AB, we should assert that that gives us 0, and then ABC should give 1, and then, well, the other one is just cake, so that one is normal, but these 2 are, this one is wrong, should give me 0. Okay, why should it give 0? Oh, yeah, so because starting from the second letter should be free, right? So so starting from the second letter should be free, which, because the example cake, that's what happens, starting from K is 0. This is an interesting problem. So basically I need to place 2 fingers, right? So I need to start out with I need to try to place the fingers in all possible positions and compare, right? So the starting thing should be, let me see if I can get, okay, so the positions of both, right? So what I did here is that this is not shouldn't be the coordinates, it should be the positions, right? Which is just the character itself. That's where I made a mistake. Yep, that's where I made a mistake. Okay. I think I need to rewrite this. So still, distance is still used as it is. Okay, stopwatch is done. Okay, so yeah, I think I'm just going to try to see what other people did. So my distance here was good. The way I calculated the alphabet also was good, right? So that one also was right. Now my helper function here, that's where I had problems. And so let's say I'm starting from, so let's say I is position in the word, and let's say this is first finger, so F1, and this is second finger. Let me do this instead. So the first finger, both start out at no positions, and then we go from there, right? And my return here that I need to do, we need to be a slightly different thing. So let me first do this. So we start out at the first position in the word, right? So something like this, 0. And then first finger is nowhere, and second finger is nowhere. So, and then we are done when we reach the length of the word, right? So that's fair. And then, how can I mute notifications here? Enable desktop. Message sound, no. Okay. Hopefully this would. Okay, hopefully this would. I'll shut off all the notifications. Okay, so if that's the case, then we are done. So return 0. Otherwise, well, we are going to return the min of both choices. So that's also still correct. But the way I calculate both choices, that's where, which was going wrong for me. So choice 1 is equal to something, and then choice 2. So for me, it's the distance is correct. So it's the distance going from either F1 to the new word at position I, so that we can count plus something, and then distance going from F2 toward I plus going to the next thing, which would be I plus 1, and then F1 would be going to, so here F1 would be I'm going to place, F1 is going to be placed in at one, so here, since I'm doing F1, so F1 would be placed at word I, and F2 would still be where it is. And then for the second one, I'm choosing to go with, so this one will still be at F1, and this one will be at word I, right? Pretty simple. And then we return the min of the two choices. Let's see, does that work? Cannot impact iterable. So yeah, the distance, so this is a word actually, and then I'm passing the word itself, right? So C1, C2, so this would be keyboard at C1, and this would be keyboard at C2. So it's character, right? So keyboard. So if it's none, then, so if C1 is none, okay, looks like it passed. Let's see the other ones. 3. And then for new, it's 3. For happy, I got 6. For year, I got 7, so it's good. Cool. So that is very good. That's the only thing I was missing actually. So let's just submit this. No need for this and this. Okay, looks alright. Submit. Oh, it will probably exceed. Yeah, I need to memorize this. So I need to memorize this. So import salary. You can. You know what? I'm just going to use a memorization table. Yeah. So memo, and then here, well, it needs to be all of them. So if I f1 f2 in memo. And then we need to return memo of this triplets here. Otherwise, well, we need to assign them. So that will be, we need to return it. So still good. Let's use this instead. So that passes. Okay, submit this. Okay, so now let's see how other people solved it and then go from there. Okay, so first let's just look at this one. So this is top down and this is the other one. So we have two choices. Type the next character using either left or right index. So we run DFS to find the minimum cost. Without memorization, the runtime is O of 2 to the power of n, and then memorization here are quite intuitive. Both fingers locations and position in push string. We have 27 locations for each fingers, including the initial hovering state. Okay. Yep. So this is pretty much like my solution. And then you can get an intuition that one of the two fingers is always located on the previous keys. So we only need to memorize the location of the other finger. So this is like, okay, okay, cool. Let's see the, if I go to contest here. Track the position of two fingers after tapping the last character. The top-down solution is a little bit complicated, yeah. Okay, cool.